Hi, you guys. Okay, so today we're gonna do a glass can tell on you. It's a lab on in glass identification. So our objective is to determine the density of several glass samples so you can determine whether or not the two glass samples originated from the same piece. Okay, so we're gonna be looking at part one only today. Okay, so at least on this video. Okay, so let's start with the materials. We have a graduated cylinder. Okay, so it's already filled up with 20 milliliters in there. I have my crime scene glass right here on this side. Okay, and then I have my scale, my balance in here, and I have my five suspects. Okay, with the glass. Okay, so one of these did it. Okay, so let's go ahead and get started. Procedure number one, it says, place the glass sample from Brian's car on a scale and determine its mass in grams. Record the mass on the data table. So this is a glass from Brian's car. So this is my crime scene or Brian's car. Okay, so I'm gonna zero it out, make sure that it's zeroed out, and then I put it in the triple beam balance. And the mass is 0.76 grams. Again, the mass is 0.76 grams. So now I am looking at, I've removed the sample from the scale, and now I'm going to repeat this step one to my other five suspects. Okay, so again, zero it out, and then I will put my suspect A is 3.77 grams. Suspect B, 9.56 grams. Suspect C, it's a 0.92 grams. Suspect D, 6.14 grams. And then suspect E, 2.46 grams. Okay, for the third procedure, okay, we're gonna, I placed 20 milliliters of water in a graduated cylinder. Okay, then I'm gonna go ahead and add glass samples taken from Brian's car to the water in the graduated cylinder. And you're gonna read the new volume on the cylinder in milliliters, okay, and record it on your data table. So again, this is Brian's car. Okay, so now we're looking at suspect A. Okay, that's 20 milliliters initial, and now this is with suspect A. Okay, so now this is suspect B. Suspect B. Okay, so I have it in 20 milliliters initial, and I will drop it. So make sure you look under the curve. Okay, it should be straight under the curve. Okay, so now we're going to be looking at suspect C. Suspect C. Okay, those bubbles are from the outside. So suspect C. Okay, so now we're gonna look at suspect D. Suspect D. There's a little bit of stuff in my particles. So that would be what? Okay, and then we're gonna do the last suspect E. Suspect E. Remember to look right under the meniscus. Oops. Okay, so on step number 5, you're going to calculate the volume of the glass by subtracting column 1 and column 2. And then after that, you're going to divide the volume of each sample by its mass to determine that sample's density. So record the density for the glass from Brian's car and from the 5 suspects' cars on the data table. Okay, so make sure you are doing that. Basically, I did made it simple for you to just go down and see which numbers fit best for your samples. Okay, so after that, you do have post lab questions, and really you just need to do part 1 for this part for the post lab. The refractive index that will be done until Monday. Okay, you guys. So I'll see you guys later. Um, Make sure you work on your stuff, and I will just see you guys later. Okay, bye, guys.